So this is problem 35 of chapter 7 of Giancoli 6th edition. So what we have is a sports car. So they give us the mass of this sports car, which is in the end, this sports car is initially moving at a certain speed VA. So here I have my sports car initially moving with this speed VA. And this car collides into the rear end of an SUV. So they also give us the mass of this SUV, but this SUV is initially at rest. It stopped at a red traffic light. Okay, so this is our SUV. Now, as a result of this collision, the bumpers get locked and the two cars skid forward until they stop. So now I have these two objects, these two cars locked together, and so they are as they are new object of big mass MA plus MB. They move together for a while, but eventually stop. Okay? And why they stop at the end? Because there is friction. Okay, so they move a certain delta x. The police officer wants to know how fast the sports car was moving. So this is our unknown. What is VA? Okay, so he wants to know, for example, if this car was above the speed limit. What he knows about this road is that the coefficient of kinetic friction between the tires and the road has a certain value. He knows this value. Okay? So he knows that what caused this combined car plus SUV to stop was friction. So how are we going to solve this problem? So the friction force is the only force involved. If I know the friction force, I know the acceleration. If I know the acceleration and I know the displacement, I can find what is the speed that these two objects are moving together. If I know this speed, I then can come back to the initial part of the problem, use conservation of momentum to find the speed of the sports car. So that's the plan, and let's start from the friction force. So the sum of all the forces is equal to MA. The only force involved in this problem is the friction force. After the collision is the friction force. Okay? The friction force is the constant, the mu, the coefficient of kinetic friction, multiplied by the normal force. The normal force in this case is parallel. There is no ramps, no angles involved. There are no additional forces in the y direction. So the normal force is just mg, where this m is the sum of the masses of both cars. Okay? And this is equal then to ma. So from here, we can find the acceleration of this combined object, sports car and SUV. With this acceleration, we can then come back and find the speed that these two cars moved together. How can we do that? Well, we can just go back to chapter 2. We know that the final speed square is equal to the initial, and the initial of these two combined objects is the v prime plus 2a delta x. Okay? I can choose a reference frame. I'm going to choose as reference frame right being positive. And so from here, what we find is that the final speed is 0. The initial, I don't know, so but now I can find. My acceleration is against this motion. The motion is to the right, so the acceleration is to the left is negative, minus 2a. The value of this acceleration I found, so I'll put it here, and the delta x is given to us. So now I have found the v, the speed that these two objects move together. Very well, so now I come back to the beginning of this problem to try to find VA. I'm going to use now conservation of momentum to try to find VA. How do I do that? Well, MA VA plus MB VB equals to MA plus NB, all together, moving together, stuck together. VA prime we just found. The masses we have. The initial speed of the SUV, which is the car B, is 0. So from this equation, we will finally find VA prime.